We have made it all the way to lesson 1-9. It is the last lesson in the first unit. Congratulations. Vocab list is very short. Inductive reasoning means using a pattern to draw a conclusion. We're going to get to that on about problem 3. The other one is not in your book, but I want you to refresh your memory. An ordered pair is what you use when you're graphing things. And they are always marked by parentheses. It's always X first, then Y. They always go in alphabetical order. Always, always, always. When you're graphing, when someone says ordered pair, number comma number, X comma Y. Always. Let's look at problem 1 in your book. Solutions of a two-variable equation. Ooh, two variables. Taking another baby step towards real algebra. Look, it's an ordered pair. Is 3, 10 a solution of the equation y equals 4x? And then they walk you through the steps. All you need to do, you know that that's the x value, so substitute that in for x. You know that that's the y value, so substitute that in for y. Does 10 equal 4 times 3? No. So 3, 10 is not a solution of this equation. Test these out. Got it, number 1. A, B, C, D. They've given you one equation, y equals 4x. They've given you 4 possible solutions, and you need to test them out. So, as we've been doing, stop the video, either work them out on your own and then check my answers, or watch with me because I'm about to figure these out as well. Please make sure you have your equation written down so that I know what equation you're working on. Then I want to know which ordered pair you're working on. So given the possible solution 5 and 20, 5 is your x value, 20 is your y value. Does 20 equal 4 times 5? Yes, it does. Take a look at letter B. What if we use -5 and -20? Well, same thing. -5 is your x value, -20 is your y value. Does -20 equal 4 times -5? Yes, it does. What about -20 and -5? That gives us the equation -5 equals 4 times -20. That really doesn't work very well. Last but not least, 1.5 and 6. So, does 6 equal 4 times 1.5? Do your thinking, do your thinking. Yes, sure does. Okay. You might be realizing that when there are two variables in an equation, there can be a lot of different answers because what you put in for x will determine y. And how many different things could you put in for x? Is there any limit? I don't think there's any limit at all. I think there's an infinite number of solutions for this equation. Good! Before we start on problem 2, I'd like you to copy this down just as you see it in your homework notebook. I'm hoping this is all review from last year. I know you did some graphing. So remember, the horizontal axis of this coordinate plane is the x-axis. The vertical axis of the coordinate plane is the y-axis. When we number the quadrants, we start here with quadrant 1 and we rotate around counterclockwise, quadrant 2, quadrant 3, quadrant 4. And then this shows you the numbers in quadrant 1. All the x values are positive, all the y values are positive. In quadrant 2, all the x values are negative, y values are still positive. In quadrant 3, both x and y values are negative, and in quadrant 4, x is positive, but y is negative. Now we're going to work on problem 2, and man, I can't wait till we get to the real thing because this is going to be a little tedious, but that's all right, it's good for you. Both Carrie and her sister were born on the same day, but Kim was born 2 years before Carrie. How can you figure this out? Well, first, you're going to make a table. When Carrie's 1, Kim is 3. When Carrie's 2, Kim is 4, and so on and so on and so on. Then you're going to turn this into an equation. If we make x Carrie's age and y Kim's age, your equation is y equals x plus 2. And then you graph it. Isn't that pretty? When Carrie was 0, Kim was 2. When Carrie was 2, Kim was 4. And so on. You plot the dots from the points that you worked out up here on the table. And then, when you have them all plotted, you draw a line to connect them. In the back of your head, I'd like you to think about how many points you need to figure out before you can draw a line. That's something to ponder for another day. Got it number 2. They want you to set up something similar on your own. Will runs 6 laps before Megan joins him. Then they run together at the same pace. So how can you show the relationship between what Will has run and what Megan runs? And they want you to set up all 3 things: a table, an equation, and a graph. I would like you to figure out 3 laps on your table. Plot 3 points on your graph. Then come back and check with me. So we know that Will gets to the track early, and he does 6 laps on his own before Megan even gets there. So Megan's run 0 laps, Will's already run 6. But then they run at the same pace. So by the time Megan has run 1 lap, Will has run 7. And then when Megan has run 2 laps, Will has run 8. You could continue this pattern going if you need to. I'm going to say 3 for the sake of saving your time at the moment. What is your equation going to be? We're going to set x equal to Megan's laps, y equal to Will's laps. Why did I choose that instead of x is Will and y is Megan? Simply because we've got the smaller number is x, Megan. The bigger number, Will, is y. Does that always have to be the case? No. It's the case for today. Just go with it. Then, here's our equation. Y is equal to x plus 6. How do I know that? 6 is equal to 0 plus 6. 7 is equal to 1 plus 6. 8 is equal to 2 plus 6. This equation fits the pattern that we figured out. And then the graph. There we go. I did not draw all the little hash marks. I didn't want to make this look too cluttered. But if I'm going to plot the point 0, can I zoom out just there we go. If I plot the point 0, 6, that means I haven't moved at all for x. This is going to be right on this axis, and I have to go up. 1, 2, 3, 4, 5, 6. There's my point. Then the point 1, 7 will be here, and the point 2, 8 will be up here. And then I draw a nice straight line using a straight edge so that my work looks beautiful. There it is, a lovely graph. The other part of this got it question, they want you to come back to the question they gave you about Carrie and Kim and think about what would happen if the difference in ages were 5 years instead of 2 years. How would this change the graph if when Carrie is 1, Kim is 6, then our point would be up here. If Carrie is 2 and Kim is 7, then our point would be up here. If Carrie's 3 and Kim is 8. Our point is up. So we're going to end up, I don't want to, of course, write on the book, but our line would be right where the edge of this paper is. So what do you notice about this line and this line? Are they the same distance apart all the time? And if they are, what's the word we use for that? I knew you all said parallel. So all we did was take the same line and scooch it up the graph a little bit. Good. You knew I was going to get back to inductive reasoning at some point. Otherwise, why would it have been a vocabulary word? Extending a pattern. This table shows the relationship between the number of blue tiles and the total number of tiles in each figure. Extend the pattern for which you use inductive reasoning. What's the total number of tiles in a figure with 8 blue tiles? Well, they've done this little chart for you. When you have one blue tile, like right here, how many tiles do you have total? 1, 2, 3, 4, 5, 6, 7, 8, 9 altogether. If you have 2 blue tiles, how many tiles do you have altogether? I'm not going to count all those. You've got 18. 3 blue tiles, you've got 27, and so on. First step, draw a graph. Graph the points. You'll notice that they're making a big deal about this being a dotted line and not a solid line. Why is that? Because you can only have the solutions at those points. You can't, for example, have 1.5 blue tiles in the pattern. That's why these, don't worry about that. Okay, so you do the table, you've done the graph, you write an equation. Phew! Got it, number 3. Using the tile figure that we were just looking at, make a table showing the number of orange tiles and the total number of tiles in each figure. Make a table showing the number of blue tiles and the number of yellow tiles in each figure. So, for both of these, we're trying to figure out, letter A, how many tiles in a figure with 24 orange tiles. For letter B, how many yellow tiles in a figure with 24 blue tiles. You know what to do. I'll be right back with the solution. So remember, we're using these pictures from your book, and we're trying to figure out, first of all, how many orange tiles in each pattern. So you make a table. Fortunately, they didn't ask too much. They just wanted a table. We don't need a graph. We don't need an equation. Yes. If you have 4 orange tiles, then how many tiles total do you have? Well, you are smart, and you realize that there are 4 orange tiles in one whole collection, so 9 tiles. And then you looked at the picture again and you said, okay, if there are 8 orange tiles, there are 18 tiles total. 12 orange tiles gives you 27 tiles total. And then you just used your inductive reasoning and continued the pattern to figure out 16, 36, 20, 45, and 24, 54. And since the question was, how many tiles will there be in a figure with 24 orange tiles? 54 must be your answer. Not too bad. Letter B asks about blue tiles compared to yellow tiles. So you go back to your picture and you realize that for every 1 blue tile, there are 2 yellow tiles. And you start your table again. Okay, 1 blue tile, 2 yellow tiles. 2 blue tiles, 4 yellow tiles. And then you say, holy cow, I'm supposed to get all the way up to 24? This is gonna take forever, unless I use my inductive reasoning. These dots here show that I really didn't think I needed to continue doing every single one. When I have 12 blue tiles, I have 24 yellow tiles, and I thought I was done. But then I looked at the question again and realized that it asked about 24 blue tiles, not 24 yellow tiles. So 24 blue tiles, 48 yellow tiles. And that is it. The rest of your homework tonight, on page 64, I don't want you to do the whole lesson check. I just want you to do numbers 1 through 4 and number 7. And we'll check them tomorrow in class. Have a nice evening.